Hello everyone. So today I'm going to work on reacting that deer herd to threats. So for example, if I go closer to the herd, they will see this wolf character and start and panic, and they will start to run away. So yeah, now they have panicked a little bit and they are starting to run away like that. Actually my wolf character is faster, so I don't have any problem catching up to them, but still they react to the wolf. That's basically what I wanted to implement, moving away from the wolf. Okay, so let's see how to implement this. And this episode is sponsored by these generous patrons. Thank you very much for your support. Right, so this is what we have at the moment. When we play the game, a herd of these deer characters will be spawned and they will continue to follow the lead character. And that's pretty much it. So at the moment deer character is resting here, so if he start to move somewhere, the gang will also follow. So now you can see the leader is going somewhere. See, the gang is also slowly following the leader. Okay, so that's what we got so far. Now I want to implement how this deer herd react to threats. So for example, if an enemy character comes near them, they should run away from him. So I have already created this third person wolf character before in this series, so I'm going to use it as the player character. So if the wolf go near them, and if one of these deers notice the wolf, they will start to run away. That's basically what I'm trying to implement. Okay, so let me open the stack blueprint first. Right, so this stack character is controlled by this AI deer AI controller. Let me open it. So this is the basic behavior the deer character has. It can be either roaming or eating or resting. If it is roaming, if the character controlled by this AI deer is the leader, he will just randomly roam around. If it is a follower, he will select some position closer to the leader and go there and roam around that position. So in that way I can keep the whole herd stick together. Right, so first, in order to implement these reactions to the threats, we need to add perception to this AI controller. So I'll add AI perception component here. Let's add site config, detect enemies, neutrals. So as far as I know, I think these how to mark characters as enemies, neutrals or friendlies, those things are not post to blueprint as I knew when last time I checked. So I'll enable all three. Right, and as the dominant sense, I'll set site. I think this range is fine. And on perception update, let's use the first one. It gives a bunch of actors. No, let's take this. All right, it gives only one actor. So yeah, let's print the name of this actor we have perceived through our senses. And let's break this and do this only if we have successfully sensed. Append detected the name of the detected character. Okay, see, they are seeing each other. That's why I get this ch tag followers. So actually I'm not really interested in this seeing each other, because I am only interested in this character seeing the wolf. So let me open the wolf blueprint. I think I already have implemented this. We do. We have this npc info. Yeah, in that npc info, let's go to the parent blueprint. Here is threat. We return true in the third person character, and since this third person character wolf is a child actor of the third person character, that is also returns true because I haven't override that function here. Okay, so if you want me to show where did I implement this, it is here. It's just a blueprint interface. If you don't have one, you can create it like this: blueprint interface. And when you go there, you can add functions. So what I did is added a new function, named it as isThread, and return thread a boolean value. And then you can go to whatever the actor you want to implement that interface. Here I have implemented in third person character, added. I have already added it. So after you add it, that function isThread will appear here. Double click on it and here set it to true, because I want this character, this third person character to be marked as a thread for this stag or DS. So yeah, and stag character doesn't implement this npc info interface, so therefore I don't have that isThread function here. So if I call isThread function on any of the characters, any of the actors which haven't implemented that npc info, it will return false by default. Right, now here I'm gonna do this is thread. I'm gonna use in that bpi npc info interface. I'm gonna determine if this detected character is a threat, and only if it is a threat, only if it is true, I'm gonna print this threat detected and print the name. Right, now see, threat detected, character wolf. Let's spawn further away from the herd. Now they don't see me. If I go close enough, they should see me. See, now they have detected me. Okay, so now we need a way to report the leader of the pack about this threat. So we have this BPI NPC interface implemented in this CH stack. So here I'll add report threat with an actor reference. What we get here is an actor. Yeah, so we should use actor. Let's call it threat. Right, now let's implement that in the CH stack. So this CH stack is the leader and this stack follower is a follower. So first I'll go to the leader and where should I implement it? Let me delete unused parts, and here report threat. So since this is the leader, he should take a decision. So what he should do is he should first run away from the threat and also instruct other animals to run away too. So I'll add another Boolean variable escaping. By default it should be false. So in the report thread I'm gonna set escaping to true. No, let's call it not escaping. What should we call it? Alerted. Yeah, okay, that sounds more professional. Right, and promote threat to a variable. Let's call it threat. And also let's add another blueprint function on alerted. No, is alerted. So we can use this to determine what character should do in the AI controller. So we need a boolean return here, yes or no. Let's add a question mark here. Right, now this stack should simply return the value of alerted variable. Right, then here also this character should run when it has a threat, when it is alerted. So for that, yeah, we use this get desired moment function to play the animation in animation blueprint. If I go to the animation blueprint, I calculate update the speed like this, get the desired moment, and from that I get the forward component and the right component of the speed. So here we can get is alerted, and if yes, we can add a multiplier to this vector like this. We can select this float based on this value. If it is yes, it should be 1. Sorry, if it should be 2, otherwise it should be 1. If the character is alerted, he should basically run, so speed should be doubled. Then I'll use this one, result of this one, instead of directly connecting it here. Right, now that's regarding the animation part. Let's go back here. So we register threat and set alerted, and we use this get move location when the AI is free roaming. Here, when the character free roams, we get this move location like this through the NPC BPI NPC interface. So here we should only return some random location if there is no threat. So we can use this is valid. If we have a valid threat, if we don't have a valid threat, we can just go to any random location. Otherwise, we should run and basically go away from the threat. So we can actually we can do the same thing like here. Oh yeah, let me disconnect this. We can make it much simpler. We can use this is valid, not this one, the other one, PO function. So based on this, we can select the target. Oh wait, no, not like that. We have to select the vector like this. So if there is a valid threat, if there is no valid threat, we should select this. If there is a valid threat, then we should find a location away from the thread. So direct now get at the location. Okay, so we can get the direction from the thread to the character itself, and using this direction, let's multiply this by, say, 5000 and add the current location so that we can go to a place that is 5000 units away from the current location in the opposite direction where the thread is. Alright, I think that's all I have to do in the... oh no, not yet. What else I have to do? Right, so in this report thread part, the leader should alert all other followers regarding the thread. So for each not report thread, let's set them alerted to true. Right, now in the AI part, when we select the next state, we should we should not go to any other states like eating or resting other than roaming. So how can we make it happen? Right, maybe here when we go to a random behavior, let's connect them like this. Let's have another branch. First we need to get controlled pawn and is alerted. Now based on that, so we can select this state. If it is true, we should be roaming. If it is false, we can use whatever the random state like this. And I think we still didn't call the report thread anywhere. Yes, we didn't. Okay, so we can get controlled pawn and call report thread. So as the thread, now I'll skip this print because I don't think I would need it anymore. It should be obvious. I'll connect the thread like this. Now for the leader, this is the thread function. So for the followers it should be slightly different. We can get leader, report thread, as the thread, connect this one, and set themselves alerted. Right, now let's see what happens. Okay, now I don't think they see me still. If I go closer, alright, I think they are trying to run away, but the leader is stuck in the position within the herd, so they can't. Okay, now only they are running away. And they are very slow actually. See, that doesn't look very good. Right, what's the error? I think, yeah, we should set alerted to true only after setting the thread. And also, no matter what, the leader should be able to run away without any issue. So for that, actually we can make the leader hidden in game and does not collide with other animals, so that we will not see the leaders, but there will still be a leader, so the pack will have a fluid motion always. Okay, so I'll make this one hidden and the capsule to custom, and I'll make it ignore pawn collisions. Let's keep it visible for now. Then for stack follower, I'll override the collision preset to pawn, because followers should still have collisions. Still they are not running. Here's the leader. Okay, to identify the leader, I'll keep the capsule visible. Alright, I think we should not have any delays. No, actually we have given this radius also 5000, so therefore we should have a much larger value here. Let's say 15,000. And also this one, I'll reduce it to 5 to 8 seconds. Still they are not running away. I think we can reduce this further. Okay. One more thing. For the lead, this capsule, I'll set it to no collision for the fall, so it will freely run away from the danger. This one, overlap all dynamic for the followers. Okay, now they are running away, but still wolf is faster, so I don't have any problem with catching up. If I go from this way, what would the leader do? Our leader is basically stuck here. Oh no, now he's running that way. So the whole pack should run that way too. Okay. Also, if the size of the herd is small, it should react much faster because less collisions in between the members of the herd. So I'll set herd size to 20 and start from here. Okay, leader is still sleeping. Okay, now only he started to run. And so the others. What's the error? Okay, why did I get that? Maybe regarding that error, we should switch back to this. This is valid, and this is valid node and have two return outputs, so that would solve the problems, but it's not a big deal. So I'm gonna stop this episode right here. So if you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below, and also the project files will be available to download. They are in the Patreon page. And thanks for watching. See you in another episode. Goodbye.